if I had asked you in June of 2024, how many years away is AGI? And if I ask you that now, what's your answer?
So I would say my timelines have shortened a bit. I couldn't really say how many years away I thought we were, last year, but probably...
Even if you're not faster or more efficient at learning that than a human would be, just the fact that you can learn from every single copy, whereas a human can only learn from their own experience, already effectively makes you superhuman.
That's right. And every time any of the instances of the model is learning something, it is shared with all the other models. It becomes a new building block that every future instances in perpetuity can leverage.
So we have Francois Chollet, the famous AI bear, saying that in 5 years, a singularity is going to arrive.
No, that's really not what I'm saying.
I would have thought at some point it would just plateau, but you can just spend $1,000 of tokens and you still get some benefit.
The reason why
For those keeping score, this is actually the second time that Dwarkesh has interviewed Francois, and the first time was on a podcast 12 months ago where they had a very lively debate about the current state of frontier AI, and I follow both of them very closely, and I believe that they both updated their viewpoints on AI in those last 12 months. So I'm really excited to see what comes out of tonight. Let's welcome to the stage Francois Chollet and Dwarkesh Patel.
All right, Francois, thanks for doing this.
Thanks for being part of our launch event.
I want to play the games, but let's talk first.
All right.
Okay, so why don't we just start where Greg left us off? We talked 12 months ago. What have you most changed your mind on since our conversation?
Right, so for me, the big update was, you remember our conversation last year, where I was describing, the main bottleneck in AI research at the time was the fact that the AI systems we had were static. So they were all entirely reliant on memorization. So at train time, they would gather, these huge collections of useful templates, like reasoning templates or bits of knowledge. And then at test time, they were completely static. So if you had a problem that could be solved by just reapplying a template you had memorized before, then it would work. And if you were to show the model with something that was actually novel, like in simple arctas, for instance, then it would fail. And that has changed. And the big update came last December in particular, but also throughout the year during the ARCRAS competition that we ran. And the big update has been that now we have models that can actually adapt at test time to something they've never seen before. So we have models that are showing real signs of fluid intelligence. And we saw that with the O3 launch from OpenAI, all of the top entries during the competition last year, they were reliant on things like test time fine-tuning, test time search, program synthesis, all of these different ways of doing test time adaptation of, you're looking at something completely new. Instead of just trying to blindly reapply memorized templates, you're trying to synthesize a model, like a program or a chain of thought that is adapted to what you're looking at. And you're doing this synthesis on the fly for each new task that you're shown.
And how has that updated your sense of how many years away we are from AGI? So I should have asked you this last year, but if I had asked you in June of 2024, how many years away is AGI? And if I ask you that now, what's your answer?
So I would say my timelines have shortened a bit. I'm also very curious to know about your timelines as well, but let's talk about my timelines. So I couldn't really say how many years away I thought we were, last year, but probably 10 years-ish. And now I think it's probably, five-ish. So my timelines have shortened quite a bit. Then again, when we ask, when is AGI going to happen, it's a bit of an ambiguous question because there are several milestones you could be looking at. There's like the moment where there's a team out there in the world that starts working on the right ideas, right? Then there's the moment where somebody builds and tests for the first time an AGI-like system, and people start wondering, well, could this be AGI? And then there's the moment where this system starts being deployed at scale. And there can be a lot of lag, actually, between each milestone. Like if you look at LLMs, for instance, LLMs had substantially been already invented in more or less their current form, back in 2018, 2019. But then for such a system to actually get, built and tested and proven to be useful for in the real world, that did not come until like late 2022. So it took actually a few years to go from starting to work on these ideas to a system you could deploy and that people would be interested in. And as for deployment, we are still in the deployment phase today. Like we're not anywhere near done deploying this technology to every problem it could solve. And I think actual AGI is going to be following the same kind of template where, at some point in the next probably couple years, some team out there will start working on the kernel of the solution, the right ideas. Then it will take 2-3 years to actually build it. And then for it to change the world, it will be like 5+, 10+ years.
I wish I'd asked you this last year because this may not be your view, but you are perceived in like the Twitterverse as a prominent bear on AI progress, or like what we've done so far in AI, and you think it's 5 years away, which I think is like incredibly bullish.
There's no doubt that my timelines are considerably longer than most people. Perhaps most people in this room, or at the very least, most people in the Bay Area tech community. Like I remember. Even before the initial release of ChatGPT, I was talking to folks in SF, and they were like, "Yeah, like AGI is coming in like 1 year." I'm like, "Are you sure?" So and this is actually a view that became sort of mainstream around like peak AGI hype around like Q1, Q2, 2023. People were convinced that AGI was like 1 to 2 years away.
Yeah.
And what was behind this narrative, and this is what it was a narrative, it was a story, is the fact that there had been this huge capability jump between GPT-3 and GPT-4, and people expected that just scaling up GPT-4, like reapplying the exact same recipe, but making it bigger, would yield the same kind of a jump in performance, the same kind of like total paradigm change. And that does not happen, that has not materialized, right? And I was saying at the time, well, no, you're not going to get AGI because that's not how any of this works. This is not going to happen. And, well, it has not happened. And now I think we are much closer because at the very least, we've identified where the bottlenecks were, like test time adaptation, for instance, and we are starting to make really good progress on these bottlenecks.
So we can, again, have a sort of testy exchange like we did last year, but our roles will be reversed. Because I've also changed my mind since last year, but I've become more bearish. And in particular, the problem you identified, which is this ability to rapidly acquire skills, this like raw intelligence, I think the models are really great at that. But I think there's this other missing thing which it hadn't occurred to me last year, which I think is actually a huge hindrance on their ability to actually be useful, which is their ability to learn on the job. So not the ability to adapt to a new task they've seen, but just the way a human employee will not be useful for the first 3-6 months they're working for you. They're building up all this context, they're learning from their failures, they're picking up small improvements and efficiencies as they work for you. And it doesn't seem like there's an easy way to slot in this key capability into these models.
Actually, because how do you define the difference between the ability to adapt to a new task and learning on the fly? It sounds like the same thing to me.
Well, if I'm calling back on something I learned 3 months ago on my job, and look, for me, it would be something like, YouTube Analytics has taught me some interesting pattern, and I have now a theory about how that interacts with how I'm producing episodes now. Calling forth that previous knowledge and having a sort of like rich understanding of it, it doesn't seem like adapting to the new problem.
Yeah. So it's simultaneously learning on the fly, learning on the job, and being able to store and recall that knowledge after the fact.
And not just a drive recall. So obviously, if you just do supervised fine tuning on something, you will like remember the facts themselves. But some sort of more adaptive. I guess we just don't even know what humans are doing, so it's hard to put into words exactly what the analogous ML procedure is. But it's a more sort of organic procedures, and just like that raw information is stored in your data bank again. So I mean, a good example here is in-context learning. I think this genuinely has the human-like ability to not only the written words in the context, but it's picked up your style, and it's picked up, like it has a very rich understanding of what you want. And you want this to persist for 3 months, 6 months. This is like what humans do when they're on a job.
And you think the memory features that are starting to crop up in most commercial LLMs, they're not up to your expectations? That's not what you meant?
Yeah, I think they work really well for coding because there's this external scaffold, which is the code base itself, which is based in language, which it can call on. But most work doesn't have this sort of this external existing memory like the code base is. And furthermore, even for coding, once you do like, I mean, this was the Meter paper that came out. Like one of the theories of why this kind of thing happens is this context rot, and especially when you have to compact the Claude code. If you ask it like, okay, we've been talking for an hour now, I need to compact this again. It just sort of like it just forgets about the hard won innovations you guys came up with together. And but okay, so you're bullish now. So what am I getting wrong?
I still think I'm less bullish than most people in tech. Most people tend to have much shorter timelines than I do.
Yeah.
But I do believe we are not that far from AGI anymore, in the sense that we know what the key problems are, and they feel like they're tractable if you just start working on the right ideas. And I do believe the right ideas are already around us. You know, they're already out there somewhere on archive and other places and in people's minds. We will find a solution. It's just a matter of a few years.
What is the solution to continual learning look like?
I think if you have the ability to learn on the fly, like adapt via just a few data points to something you've never seen before, you've already solved the problem, because the remainder is just the ability to store. So you're like exposed to some new task you've never seen it before. You model it very quickly, very efficiently, as efficiently as a human could. And then that model, you take it and you store it. And next time around, when you encounter a task that's similar, you can either reuse the same model, or you can decompose that model into its core pieces, its core abstractions, and then you can reassemble them into a new model, right? So continual learning is going to look like you're going to have a big database of abstractions, of like reusable programs and templates, building blocks that you can use to synthesize new models of new tasks on the fly. And that big database is going to be global and shared across all your different agents, all your different instances of your AGI, and it's going to be also shared across every new task the system sees. And over time, it gets bigger and bigger and richer and richer. And as it gets richer, every time the system sees a brand new task, it's able to model it much more efficiently, much more quickly, because it has access to these more abstract, more higher level building blocks. Kind of like, if you look at software engineering, software engineers today, they're able to move faster on difficult problems because, well, not just because of GenAI, but because they're able to draw upon things like GitHub, like tons of reusable open source libraries, utilities that they can just reassemble. If you're a programmer in the 1970s, for instance, you would have to do pretty much everything yourself, so you'd be much less productive. I think in general, AGI as a system, if you zoom out a lot, if you look at the system level, AGI is going to look a lot like the software engineering profession as a whole. It's going to be like a bunch of like individual AGI agents, that's like the programmers. It's going to be the GitHub-like database of abstractions and so on.
Interesting. Maybe this is a sort of key point that is worth emphasizing, that whenever we think of AGI, we think of a substitute for a human, or whenever we think of something superhuman, we're emphasizing the superhuman intelligence it will have, this ability to solve puzzles that maybe humans will get 5% on ArcAGI 5, but the AI will get 95%. But the point you're making is that if you have this ability to learn from everything every copy sees, so if what any model is seeing, even if you're not faster or more efficient at learning that than a human would be, just the fact that you can learn from every single copy, whereas a human can only learn from their own experience, already effectively makes you superhuman.
That's right. In the same way that current LLMs, they have superhuman knowledge, like they've seen a lot more content than any of us. In the same way, the ability of these models that can adapt, their ability to learn is going to be superhuman, because it's not just going to be like one AGI in a room learning from one task at a time. It's going to be millions of AGIs learning in parallel, things that are actually synergetic from each other. And every time any of the instances of the model is learning something, it is shared with all the other models. It becomes a new building block that every future instances in perpetuity can leverage to build its own models of new tasks.
Yeah. Okay, so this very much sounds like kind of like a singularity to me. Okay, so we have Francois Chollet, the famous AI bear, saying that in 5 years a singularity is going to arrive.
I mean, it depends. No. That's really not what I'm saying. It really depends. I do believe AGI is a technology we're going to build, and when we build it, there are going to be very, very broad implications. I tend to disagree with the way people describe the singularity, or at least the way it's been described in the past by folks like Ray Kurzweil, for instance. But what's your definition of the singularity?
Just the same way as when you're thinking about models today, I think you should look more at their economic usefulness rather than their raw intelligence at a benchmark. Like OpenAI or Anthropic make on the order of 10 billion in ARR, and like Kohl's and McDonald's make more than that, right? So what explains this missing gap?
Is McDonald's an AGI?
Exactly. And if it had AGI, I think they should be making more than $10 billion a year. Just that way, I think like singularity should also be defined in terms of there should be more than 30% a year economic growth because you have just this rapidly doubling AI population rather than what is the capability of any single individual model.
So I guess the way most people describe the singularity is that it's going to be this new state of the world where everything is changing exponentially all the time. And everything's changing so fast that biological humans, have no hope of adapting fast enough. And I generally tend to disagree about narratives around exponential improvement, because exponential improvement is not something that you see in real life in any system. What usually happens is that if part of, everything is systems. And if one component of the system is no longer the bottleneck to its performance, then suddenly it's another component that becomes the next bottleneck, and so on and so forth. And so if the intelligence of software is no longer a bottleneck, something else will be the bottleneck. Let's look at scientific progress, for instance. If your ability to model data, produce new theories, come up with experiment ideas and so on, if that sort of intelligence is no longer the bottleneck, then the next bottleneck is going to be your ability to collect data, to run experiments. And if that's no longer the bottleneck, it's going to be something else. And the thing about the world is that it's mostly made of humans, right? Humans are full of bottlenecks. And if you introduce AGI into the system, you're lifting some bottlenecks, but you're still looking at this big system that's mostly people, right? So it's not going to move like exponentially faster just because you've made software intelligent,
Well, I think just saying that there's bottlenecks doesn't tell us anything about what the rate or duration of the growth will be. For example, the world economy today has a bunch of bottlenecks. There's cost, disease, there's many other things. Yet for 300 years, we've been able to manage 2-3% global economic growth, which is like tremendous that you can do that over 300 years while having a bunch of bottlenecks. Before that, it was lower growth. And you could have much more growth as this, and that could still be compatible with bottlenecks still existing. And that's the reason you would have 30% growth and not 3,000% growth. But it just becomes a sort of like, actually, you got to like do the numbers rather than gesturing at bottlenecks to figure out what that growth number should be.
Usually when you see an exponential increase like this, it's an increase in either an input or an output of the system. It's not really an increase in the things you care about. For instance, if you look at economic growth, is our lifestyle improving exponentially? I'm not sure. Like if you look over the past 50 years, I'm not sure that that's been true. Even though, the economy was obviously, improving at several percent a year. And you could look at science as well. I don't think so. Today, if you look at science as a system and you look at its inputs, like the number of researchers that are active, or the amount of compute that we are dedicating to science and so on, we are putting into the system dramatically more resources than 50 years prior or 100 years prior. But if you look at the output, if you look at the magnitude of scientific discoveries and the pace of scientific progress, I'm not convinced that science is moving faster today than it was 100 years ago. And even though we had 100 years ago, we had much fewer people working in physics, for instance, or chemistry. But the impact of their discoveries was much greater. And part of that is just because they could work on low-hanging fruit. They had more more freedom to work on the important problems that we are not already solved. And the more time passes, the harder it is to make that same magnitude of impact. Like in some fields, the very first paper to found the field had more impact than every subsequent paper, for instance. So just because science is, like, for instance, consuming exponentially more resources doesn't mean that science is moving exponentially.
I had so many questions for you about ArcAGI, and we got nerve sniped by macroeconomics. Just real quick on that, I want to ask one more question on ARC before Greg kicks me off. The benefit with AI in terms of economic growth is that even though, I mean, in any domain, over time, it just takes more inputs to get the same result. But we've been substantially limited in human civilization by the fact that over the last 50 years ago, 100 years ago, there was this demographic change where the human population actually stopped increasing, so that you wouldn't just get this increase in growth from inputs, whereas the AI population can keep growing exponentially because the inputs can produce more outputs, which is more data centers.
That might not actually matter. Like, for instance, I don't think science right now is bottlenecked by intelligence itself. So having infinite intelligence is not going to yield infinite results.
Yeah.
In my opinion.
Let me ask you one more ArcAGI question before Greg has to kick us off. So one thing I found super interesting was that on ArcAGI 1, you have you have inference scaling, but the fact that inference scaling keeps working, the law graph really doesn't do it justice, because you don't see the stupendous increases in thinking that are still producing marginal gains in score, which are obviously very diminishing at some point, but there's still some gain, and I'm actually quite confused about this. So if O3 high takes 43 million tokens to get 50 or 60%, why is that 40th millionth token still making it smarter? Like, what's happening at the 1,000th page of its thinking that's giving it a marginally better answer? I would have thought at some point it would just plateau, but you can just spend $1,000 of tokens and you still get some benefit.
So I think if you run it, indefinitely, you would start seeing it plateau in the sense that there are going to be some problems. There's a subset of arc space that is simply not part of the search space of the model. So no matter how deep you search, you're never going to find these solutions. But the reason why you see these returns is just that, well, some of the solutions are just very deep in the search space, and you need to run the search long enough to get to them. But ultimately, though, I don't think a system that needs to expend enormous amounts of compute at this time to solve simple puzzles that a child could solve, I don't think that's AGI. It looks more like brute force to me. When it comes to intelligence, efficiency, like compute efficiency at this time, is not just a feature of the system. It's not a nice to have. It's actually it's part of the definition of what intelligence is. Intelligence is about doing more with less. It's making the best use of your resources. That's what intelligence is. It's data efficiency. It's compute efficiency. So if you look at chess, for instance, if you have to look at every individual move on the chessboard and then all the subsequent moves in order to find the best move, it doesn't seem like intelligence to me. Intelligence is more being able to look at a few things because you have limited attention and instantly find the optimal move, like a chess master would do.